So. Cool. All right. Decide. So it says the graph of, man, why is it so tiny? Good grief. How do y'all blow this? Like that? There's gotta be something. Huh? Here. Yeah, because y'all can't see that. This ain't gonna work. And that's not working either. And it, aha. Control plus, by the way, just so you know. All right. Aha. 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 All right. Decide whether y equals f, negative f of x is a reflection about the x-axis of the graph or about the y-axis of the graph. The key here being is that if you have y is equal to negative f of x on the outside, basically you can think about this as negative y equals f of x. Everybody with me so far? Oh, y'all can't see what in the world? There we go. Does that make sense? So if the negative's on the y value, so if the negative's on the outside, that means you're reflecting over the x-axis. Because remember, reflections are crisscross. To reflect over the x, make y negative. To reflect over the y, make x negative. Everybody cool with that? So if you see negative y, which is negative on the outside, means reflect over the x. If you see something like this, so you see f of negative x, now the negative's not on the y, it's on the x term. So then you would reflect over the y-axis. Everybody cool with that? So that's the main difference between the two. If the negative's on the x, reflect over the y. If the negative's on the y, reflect over the x. Everybody cool with that? So in this case, this would be a reflection over the x-axis. That is true. Negative y, reflect over the x. Match the graphs with the functions. All right, so there's a couple of things here that we want to take a look at. First, this first one is sloping down. All right, so we know there needs to be a negative in front. So that gets rid of this one, for example, these. Also, it's quadratic. The way I know that is because it's smooth, right? If it was an absolute value function, it would look something like this. Y'all see the difference? Absolute value, V. Remember, those value functions look like a V, right? Whereas quadratics are parabolas. So in this case, let's see, let's pull this up a little bit. We can see that the vertex on this parabola seems to be, let's see, 10, 9, 8, 7, 6, about 6, and it's sloping downwards. So let's see, we got a negative in front, but then we're gonna plus 6. So this is the one I would choose for that. Are y'all looking at the same type of problem on your things? Okay, good. But this is exactly the one I would choose for this particular situation. All right, now let's take a look at this situation here. In this situation, we once again have a parabola, so it's quadratic, but we are at 1, 2, 3, 4, 5, 6 to the right. So if it's 6 to the right, I know that it should be some kind of x minus 6 on the inside, because remember, the inside is left or right. So in this case, and it's sloping up, so it's going to be positive on the outside in this case. So this is what I'm looking at. We got negative 6 on the inside, squared. So that's what we're going to pick for that one. Now the last two are obviously absolute value one. So what we're going to do is we're going to say, okay, we are moving 6, probably 6, I'm guessing, but we're about to find out. Nah, it's 2. All right, so we're going to shift 2 to the left, and it's sloping downward. So that means it should look something like, it's to the left, right? So it should look something like this. We're adding on the inside because it's shifting to the left, and it's sloping downward, so there should be a negative in front of it. And here it is, right here. So take all the knowledge that you got and work through these, basically. I'm not going to do the last one because I just want to move on to the next section, but you guys get the idea. All right, same thing for this one. Use the transformations as a graph. You can easily see you're adding 8 on the inside. So if we're adding 8 on the inside, that means that we're going to be, so if we have x plus 8, that means that we're going to be shifting to the left. It's on the inside, so that means left or right. But since it's plus, we're going to be shifting to the left. So therefore, we're looking for something that shifts to the left 8 units, and that is D in this situation. Same thing, we literally just did this problem earlier, so I'm going to skip it. Use the transformation of the graph to determine which one this should be, to graph this x function or whatever. All right, guys, there's a couple things you could do here. If you wanted to, you could actually back solve and just plug these numbers in and see if it works. But the first thing that I'm going to do is I'm going to use process of elimination. It's multiple choice, right? So in my mind, I'm thinking like this. First of all, I know for a fact that the intercepts, remember, we have when y is equal to 0, that's the x-intercept. When x equals 0, that's the y-intercept. Remember, math builds on itself. So in this case, I can automatically tell that if you have something like y equals 13 over 2 x to the 4th, the intercept's going to be at 0, 0. Why can I tell that? Because if I plug in 0 in here, obviously that makes everything 0. If I plug 0 in here, that makes everything 0 in that case as well. Does that make sense? So obviously it's got to be 0, 0. That's the only answer that makes sense. That said, I can automatically, let me hit control minus so you can back up a little bit, but I can automatically tell that A and B are out, right? Because their vertex, basically the intercepts are not at 0, 0. Y'all see how the intercepts aren't at 0, 0? So that leaves me only C and D. And all of a sudden, I've got a 50-50 shot, even if I'm not 100% sure. Just by taking a look at that, I can tell. Now, to figure out which one it should be, think about it like this. You got 13 over 2 x to the 4th. 13 over 2, is this bigger than 1 or less than 1? Bigger than 1. Remember, if your number on front, if your A value is bigger than 1, that means you're going to have a vertical stretch. If your number is between 0 and 1, that's a vertical compression. So if your A is greater than 1, you have that stretch. If your A is between 0 and 1, it's a fraction less than 1 but greater than 0, you have that vertical compression. So which of these between C or D looks like it's a vertical stretch? D. Now, that's just on looks alone. I could actually plug this number in and check. So if I plug 1 in, so if I plug 1 into my function, I get y is equal to 13 over 2 times 1 to the 4th. I get y equals 13 over 2, and that's it. So check this out. I know the point 1, 13 over 2, should be on here, and so boom, D is my answer because it's the one that has 1, 13 over 2 on it. Whereas this is 1, 2 over 13. So you literally can just plug the number in if you want to, just to check and make sure that you're good to go. Now the actual test only has 16 problems, I think, 16 or 19. I can't remember, but it's something like that. So don't freak out because there's 36 questions on the review. All right. Transformations, this is another kind of take on this. it's a negative in this case, and it's odd. So let me pull this up again. But, oops, wrong one. It's a negative this case, and it's odd. We know that odds in general, odd polynomials in general look like this, right? Odd polynomials in general should look like this. And therefore, what I mean by odds, guys, is if you have like x cubed or x to the fifth or x to the seventh, you know what I'm saying? So odds should look something like that. So if I have a negative odd, like negative x cubed, then it should look like that. Okay. So therefore, that automatically gets rid of A and B. Now the next thing I need to do is look at basically what differentiates C and D. Well, one difference is that C has the intercept at 0, 7. Well, that makes no sense for this problem, right? Because if I plug 0 in here, then I'm just going to get 0 out. Therefore, D is your answer. Y'all see how I'm kind of using just process of elimination here? Think about the things that you already know. You don't necessarily have to do anything fancy to figure it out. Same thing here. I know the types of shifts that I'm going to have. There are 2 shifts here. What are the 2 shifts going to be? 6 to the right and up 6. So it's 6 to the right, up 6. A is out, B is out, C looks like it, D is out, it's C. Y'all see how simple that is? So don't spend, like, the main thing is you want to make sure that you get to all the questions, of course. I mean, you got, what, 50 minutes on 16 problems. You'll have time, but I'm just saying, wherever you can, just get rid of answers that make no sense. Write the function whose graph is x squared, but it's shifted to the right 9 units. So in this case, we're shifting to the right, so it needs to be on the inside. So it'll be x minus 9 and then squared, because this needs to be on the inside of my function. All right, we're rolling quite nicely through these. So let's keep it going. Write a function whose graph is y equals the square root of x plus 3, but it's reflected over the y-axis. Now here's the key here, it's reflected over the y-axis. So that means if it's reflected over the y-axis, remember, if it's reflected over y-axis, what needs to be shifted? What needs to be made negative if it's reflected over the y-axis? X. So we know there needs to be a negative x in this situation. So we're going to have y equals square root of negative x plus 3 should be your answer. If it was asking me for the reflecting over the x-axis, it's actually reflect over the x-axis, then I would do y equals negative. If I was reflecting over the x-axis, so reflect over x-axis, I would put a negative in front of the y instead, which means to get back to just y equals, I'd have to multiply negative y out by everything. You know, with y equals negative root x minus 3. Note, that's very important. If it's reflecting over the y, put a negative on the x. If it's reflecting over the x, put a negative on the y. Okay? Also, order does matter. So for example, let's say I said something like, you can write this down because this is not on there, but I'm just saying, like, what if it says something like y equals, I don't know, square root of x, and then I want you to shift, or actually, instead of that, I want to say reflect over the x-axis, then shift up 2. if I said something like this, why is it not updating? Oh, more technology. It works when it wants to. But basically, really? It's updated. All right, so reflect over the x-axis, then shift, and then we want to shift up 2. There we go. There's the rest of it. So what we're going to do in this case is we'll do this first. So reflect over the x-axis means I put a negative where? You reflect over the x-axis, where do we put the negative? In front of y, so you do that first. And then I'm going to go ahead and rewrite it as y equals negative root x. But no, then it says, then shift up 2. So then I'll put a +2 on the outside. Note the order does matter, because if I said shift up 2, then put a negative, that would completely change everything. In other words, it's the difference between taking this, shifting it, say, to say -2 down, and then reflecting the whole thing like that. Y'all see that reflection, versus just reflecting the first part. Y'all see 2 very different situations. Okay, so just be careful about that. Make sure you do it in order. All right. Write a function whose graph is y equals x to the third, but shifted down 6 units. That should be pretty simple. X to the third is what I wanted, -6. And pro tip, to create an exponent, just hit Shift 6. You don't have to keep clicking down here if you don't want to. But if you hit Shift 6, that'll do that. Another thing is, for pi, for example, just write pi, it'll automatically create it. Or if you want a square root, hit SQRT. Does not work. Never mind. It does on some applications. It doesn't on this one, apparently. All right. Graph the following function using the techniques of shifting, compressing, stretching, reflecting. Start with the graph of the basic function shown to the right. Find the domain and range of the function. Oh, it just looks painful. All right, so let's walk through this. So the first thing we're going to do is we've got h of x is equal to square root of x. I mean, we're almost 1/3 of the way done. We're doing pretty good. We got h of x is equal to square root of x minus 6. So the first thing we're supposed to do is choose the correct graph. That means we're moving 6 to the right. This is on the inside. So I'm going to go with B. Yeah. Next, we're going to say find the domain. Remember, domain, that's where my x can go. All right. So in this case, the lowest x value I've got is 6. Everybody see that? The lowest x value I've got is 6. So the domain is going to be in I would use bracket 6 and then infinity parentheses. Why am I including this value 6? Why is 6 included in this situation? Because I promise you somebody's going to screw this up. So let's make sure we try to avoid that. Why do I put 6 in a bracket, not a parentheses? Yes. Exactly. It's the starting point, and it's actually a part of this answer. So what do I mean by that? Basically what I'm saying is, if you have a situation where you do h of 6, it does actually exist. Square root of 6 minus 6, of course, is square root of 0, which is just 0. So it does exist. However, anything immediately less than 6 no longer exists. So for example, h of, I don't know, 5.9. Immediately you end up with equals 5.9 square root -6, which is equal to square root of -0.1. Obviously, this is not real, right? You cannot take the square root of a negative in the reals. So therefore, we're gonna say, okay, nah, we're not gonna even mess around with this. But 6 itself is included. So that's why we use the bracket instead of the parentheses. I know you might be like, why do you keep harping on brackets and parentheses? Because I promise you, somebody's gonna screw this up. Promise you. Don't let it be you, is all I can say. All right, range. The range is gonna be from 0. Should I use a bracket or parentheses for the range? Should I use a bracket or should I use parentheses in this situation? Bracket, because once again, I literally just showed that 0 is a part of the range. This is the lowest I can go, right? It's the lowest answer you can get. And so it's gonna be from 0 to infinity. Remember, domain talks about where my x's can be. Range talks about where my y's can be. Domain talks about what you can put into your function. Range talks about what you can get out of your function. Everybody see, does it kind of make sense? Ish? Yeah, I know it can be kind of confusing, but hey, we've seen worse. All right. Which of the following transformations y equals fifth root of x need to be applied to the graph? F of x is equal to negative root 5x. Select all that apply. In this case, we see there's a negative in front of the whole thing or a negative in front of the y, and therefore it's a reflection about the x-axis. There's really nothing else that's happening here, so I think we're good. And then, okay, root ones are weird. Root odds. Let me clear frame so y'all can see what I'm actually doing here. But basically, if you have something like a even root, like the square root of x or something like that, okay, you got an even root, then that, as we know, looks like this, or any even root, because there's a, or like the fourth root of x or anything like that, looks like this. Whereas odd roots have this funky looking thing here. So like this would be like the third root of x or something like that. So obviously, if I do negative cube root of x, then that would take this and reflect it like that. So that's why A is your choice in this situation. Okay. So the domain is from negative infinity to infinity. You can go as far negative as you want because it's odd. Go as far up as you want because it's odd. Remember, if it's even, that's where you have the restriction. Same thing for the range. So once again, negative infinity to infinity. Not what I was trying to do. Let's see. And the same for the other one. Oh, no, what else? What am I missing? Oh, I didn't. Oh, yeah. All right, this is more about using graphs, but I want to kind of get to something that's maybe a little bit different. I don't want to just be doing this all the time. I think we kind of exhausted this idea. All right, now we're getting into the stuff that we just hit. And I think this is a good time to take our 5-minute break. So we'll take 5 minutes. These last 20 questions, I'm gonna kind of rush through them. And then I'm gonna see if anybody has any issues with or any questions on lecture 7 that I'm sure everybody's already watched. Right? Right? That's what I thought. Well, good thing for you, it's already posted. But like I said, I wanted to prepare you guys for test 2. And I feel like some of you all appreciate that right about now. All right, take your 5-minute break. We'll reconvene at 6:08. We'll rush through the rest of this review and then that'll be that. You take a power nap. Hey, look, hey, look, it ain't got nothing to do with me. For those of you who did not know what I was just talking about, it was in an announcement that I made 2 days ago. Week 7 resources. I did a whole record. It's almost an hour long. It's everything you need to know just from lesson 7. I mean, really, like, listing all zeros. I mean, it's on YouTube. You can turn the captions on if you want. You can play me at what? All the way up to 2x speed if you like to do that kind of thing. So, yeah. One more minute, we'll get back to it. Our power functions. These functions consist of stuff like f of x 11th or 111th or 1011th. It just becomes more. It just means you can draw it without ever looking your hand off. Because the 0 there is what? Also quadratic. Does everybody see that? So this 0, you can see are 3 with a multiplicity of 1, -4 with a multiplicity of 2, and then it's of degree. You can write it in back and forth. All right, guys, let's knock the rest of this out. Oh, yeah. That'll be a little bit quicker. All right, I'm gonna cover these problems. I think they basically cover the rest of the types of problems you're gonna see, so let's knock this out. First thing we're gonna do is says match the function to the given graphs. To do this, what I'm gonna do, real simple, I'm gonna figure out where the vertex is and go from there. So to find the vertex, we've got, I'm gonna rewrite this problem. We got x squared minus 4x plus 2. Y'all should be experts at finding vertexes at this point, right? We're gonna use negative b over 2a, which we use like 1,000 times at this point. Negative 4 over 2 times 1 gives you positive 4 over 2 is equal to 2. Told you I was gonna go fast. Then we got f of 2, in this case, is gonna be 2 squared squared minus 4 times 2 plus 2, which then gives you 2 squared is 4, you end up with 4 minus 8 plus 2, let's see, you end up with negative 2. Sorry, that was 6 minus 8 is what I did. And then there we go. So the vertex has to be at the point 2, negative 2. All right, we good? All right, so now I know that the vertex is at 2, negative 2. All I got to do is figure out which one it is, and it looks like it's B. Y'all see how quick that was? Really doesn't have to be super duper complicated. All right. What's the next one? Oops. 20. All right. So it's question 20. For the quadratic function, that junk, whatever it is, answer parts A through C. So I'm gonna rewrite the problem here. F of x equals x squared minus 2x minus 8. And if you want to do the problem that you're doing on your question 20, should be similar, not necessarily exact same, then you definitely can. Indeed, I encourage you to. All right, so let's walk through this. The first thing we're to do is find the y-intercepts, okay? To find the y-intercept, basically all you got to do is look at the constant. In this case, the constant's on the end, where it usually is negative 8. So the y-intercept is negative 8. Don't believe me? Plug in 0 for x. It will make everything else go to 0. So yeah, Y-intercepts on the end. So that shouldn't be too hard. Excellent. Ooh, I skipped a whole, whoa. How did that happen? That's weird. Okay, all right, let's go back to the beginning. I'm sure you're like, where is he getting this from? All right. Graph the quadratic. Okay, does the graph open up or down? In this case, we've got a positive in front of our biggest term, therefore it opens up. Right, it's positive x squared, so it opens up. What are the coordinates of the vertex? Well, like I said, we know that's negative b over 2a. Real simple, real easy. We're going to do negative 2 over 2 times 1. That's going to give us positive 2 over 2, which is just 1. And then we plug that into our function, do f of 1, which ends up being 1 squared minus 2 times 1 minus 8, which gives us 1 minus 2 minus 8, which is negative 9. So that is our vertex, 1, negative 9 is the vertex. So we're going to do that. Parabola opens at 1, negative 9 and up. All right, what is the axis of symmetry? Well, we kind of already did that. Type as an equation, just I guess x equals 1. That's what we did to figure it out in the first place. What are the x-intercepts? Now this is tricky a little bit. So remember, for an x-intercept, we want y to be equal to 0. So basically, if you have f of x is equal to x squared minus 2x minus 8, what we want to do is set this part equal to 0 and solve for x is the idea here. All right, so to do that, we need two numbers, multiply to give you negative 8, but add to give you negative 2. Those two numbers are going to be x minus 4 and x plus 2 in this particular case. If you need some quadratic factoring, go back to extra lecture notes where I did quadratic factoring, a whole thing on that. So you can go back and practice if you need to. We've got x minus 4 equals 0 or x plus 2 equals 0. So you know with x is equal to 4 or x is equal to negative 2. So therefore, those are your x-intercepts. So type as integer or decimal. Okay, 4, negative 2, 2. Separate with commas. Y-intercepts is negative 8. Use a graphing tool to graph the function. All right, let's see if I can figure out how to use this thing because I don't like using it, but it is what it is. All right, so we got 1, negative 9. Looks like it's about here. Boom. And then we need the point. I'm going to use the y-intercept at negative 8 just to make my life easier. Ooh, that's not what I wanted. So clear. Yes. This is what we want. We want this and that. Boom. And save. All right. Cool. All right. Domain of the function. Well, it's everywhere because there's no restrictions on x. I can plug whatever I want to in for x. So it's going to be from negative infinity to infinity. Luckily for me, it was still on my clipboard. The range, however, the lowest point we can get to is negative 9. So basically, we'll start with negative 9 included with the bracket. And then it can go all the way to infinity if it wants to. It can go as high as it wants to. The lowest value I can get is negative 9. Determine which function is increasing. All right, it's increasing everywhere after x is equal to 1, right? It's going up everywhere after x is equal to 1. So therefore, we're going to use, I think they use brackets, if I'm not mistaken, for interval notation, even though I think that's stupid, but well, this is what it is, in 1 to infinity. as opposed to it's decreasing everywhere below 1. Remember, intervals, we're only talking about the x values. We're only talking about the x values. So negative infinity to 1 included. And the next one I said was 22. All right, determine without graphing whether the given function has a maximum or minimum value and then find that value. When it's talking about a minimum value, it's talking specifically about the y value. Does that make sense? We're going to use the x value of the vertex to find the y value, but it's asking for the y value. So just be careful of that. Make sure that you understand that that's what it's actually asking for in this case. All right, so we got 3x squared plus 30x minus 9. In this situation, we got negative b over 2a because we're trying to figure out maximum or minimum. We got negative 30 over 2 times 3, which gives you negative 5. All right. So but it's opening upwards. That means it's going to have a minimum value. So it's got a minimum value, and the minimum value is, well, 3, and then negative 5 squared plus 30 times negative 5 minus 9. Let's see, 25. 25 times 3 is 75. But you all, if I were you, I would just plug this into your calculator and don't do what I'm doing. I'm just hard-headed. See, negative 75 minus negative. I just don't like I don't like calculators. It's just my thing. All right, but you got negative 84. So in this case, that is the minimum value. It's actually negative 84. Remember, b over 2a, this is just your axis of symmetry, right? This just tells you your x value of the vertex, not the y value. You have to plug in to find the y value. It's a very important piece. Be careful. Make sure that you actually do it. All right, 24 and 25 I have written down. So let's take a look at those. Suppose that a manufacturer of a gas clothes dryer found that the unit price P dollars is whatever that is. All right. So I'm going to rewrite the problem. And by the way, guys, this is a good practice. Whenever you have a word problem, is to kind of like write down the pieces you think are the most significant. That way you don't have to reread the entire problem again. All right, what is the unit price should be established to maximize revenue? What is the maximum revenue? All right, it should be real simple. We're trying to find the unit price. We want the price, so we want P, to max revenue. So in this case, once again, use negative b over 2a. Real simple. Negative 27,000 over 2 times negative 9. Oh, Lord. Let's see. That'll be 1,500. Y'all check me on that. Just want to make sure I'm right. Yeah, 1,500. Okay. And cool. So what I'm going to do then is that should be the price. Because remember, that's the P value. You know, that's our X, if you will. So that's going to be 1,500 right there. Boom. The maximum revenue, on the other hand, I'm not going to do that in my head. We're going to do 9 times 1,500. Yeah, no, I'm not doing that in my head. So I'm going to plug that into my calculator here. Put that junk on scientific. And we're going to do 1,500 squared. Yeah, no, I'm not going to do this in my head. And We want to make that negative plus, and then I'm going to put in parentheses 27,000, excuse me, times 1,500. Close the parentheses, and I get 20,250,000. That must be known. All right. I'm just saying, that's a lot of money. All right. Now we look at 25. Let's take a look and see what we got here. Use the graph of the quadratic function f to determine the solution. Solve where f is greater than 0. All right, so f is greater than 0 just means where in the world is this thing above the x-axis? That's what that means. All right, so it's above the x-axis, below -4, right? You see it's below -4 and a greater than 4. So basically, it's in between the interval -infinity. That's why I hate these things. -infinity to 4 or -4, and then union 4 to I'm making a mistake. Can anybody tell me what's the problem that I am making right now? Yeah, what's wrong with this? Right, and shame on me because I literally wrote this on the board on Monday, right? If you see greater than strictly, we use parentheses. If you see less than or equal to that bar, that means you use brackets. And so, yes, I would have gotten this problem wrong. And by the way, guys, there would have been nothing I could do about it either. All right, so we use brackets for the bottom one, and that's going to be between these two values. So that should be a little bit easier to write. We use brackets, -4 to 4. That's where it's below 0, less than 0. Everybody cool with that? So be careful, be careful, be careful. Be more careful than even your teacher. All right, what's the next problem I wanted to do? No, I want to do 26. All right, solve the following inequality. Let's see here. All right, so we got here, we got x squared minus 6x plus 8 is less than 0. And if you want to write this problem down or the similar problem to it, go ahead and do that. I'm going to move quite quickly here, just so you know. All right, the first thing I need to do actually when solving an inequality is to factor this thing. So the first thing I'm going to do is factor. So if you want to write the steps, you could say, I don't know, factor, whatever. Two numbers multiply to give you +8, multiply but add to give you negative. So if they multiply to give you a positive but add to give you negative, that means they're both negative. And it's pretty easy to tell this would be -2 and -4, less than 0. And then the next thing I'm gonna do is solve. So I see that my two answers should be 2 and 4. So that's the first thing I'm gonna do. Then I'm gonna set up a number line. Set up number line. I'm gonna set up a number line like so, with 2 and 4 on it. And I'm gonna pick some test points. I'm gonna take test points 0, 3, and 5. And remember, these test points are used to determine whether my function's above the x-axis or below the x-axis. So all I'm trying to determine. So in this particular situation, if I plug 0 into that first one, so if I plug 0 in here, that gives me a negative. If I plug 0 in here, that gives me a negative. Negative times a negative is a positive. So this is positive. If I plug a 3 into the first one, I get a positive. But if the 3 into the other one, I get a negative. So the answer ends up being negative. No, it doesn't matter what the answer actually is. Y'all see that? Only thing I want to know is it positive or negative? Same thing with 5. If I plug 5 into that first one, I get a positive. If I plug 5 into the other one, I get a positive. Positive times a positive is a positive. So that, now I can tell which intervals are positive and which are negative. Now that I know that, remember the question asked, where is this less than 0? Therefore, which interval do I want? Two to 4. Well, parentheses, right? That's the answer. Now, what situation would there be no real solution? Will there be no real solution if, say, all of them were positive? Does that make sense? If they were all positive, or they were all negative, if they were all, you know, in this situation, if they're all positive, you just say no real solution. Or there might be just one solution or something like that. In which case you wouldn't use an interval, you would just use the number itself. All right, I think the next one I wanted to look at, I think I skipped down quite a bit. I wanted to look at 34, yeah. All right, let's look at one of these problems. All right, the price P in dollars of a certain quantity obey the product demand P equals -1 X plus 200, okay? And answer parts A through E. All right, find a model to express revenue as a function of X. So we know R is equal to X times P. So a revenue function, or R of X, will be equal to X times -1/9 X plus 200. This is what we talked about last week. Just replacing P because that's the thing I don't want. Everybody cool with that? I'm just replacing P because that's what I don't want. Multiply it out, I end up with -1/9 X squared plus 200 X. So -1/9 squared plus 200 X. All right. What is the domain of R? Domain of R. Well, I want to think about this. Well, the biggest value that X can be, the way I look at it is like this. This is a function that looks kind of like this. So this is the largest, basically, I could go with it. So that said, all I need to do really is just figure out where that is. This is obviously an X-intercept. So I can just say 0 equals, and I can factor X out. You end up with -1/9 X plus 200. If I set that second part equal to 0, -1/9 X plus 200 equal to 0, I end up with -1/9 X equals -200. And if I multiply by -9 on both sides, I get 1800 is equal to X. So basically just solving for that X, the second X-intercept. First one's 0, obviously. But by solving for that second X-intercept, I can see the bound where it no longer makes any sense. So it's going to be between 0 and 1800. Also, by the way, if you just take the denominator and multiply it by this number, that's the answer. Just saying. Or if you let P be equal to 0, the same thing. Up here. It might be a little bit easier to do it that way. Just let P be equal to 0 and then solve for X. All right. What is the revenue if 250 units are sold? That shouldn't be too hard. Basically, you're just going to do R250 is equal to -1/9. 250 squared minus 200 times 250. Oh, Lord. All right. And plus. I was about to say, that doesn't make any sense. It's a good chance that's just going to be half of the last part. I mean, I've been doing this for a minute, so I kind of caught on to that. You got 50,000, and then you're going to subtract, we'll put it in 1/9 times 250 squared is 625 2. Oh, never mind. 43,055. So that's what I'm getting. 43. Oh, 3. 56. All right, what quantity X maximizes the revenue? For that, once again, we're looking at our revenue function here, and we're going to do negative B over 2A. This is the stuff y'all been doing for a while at this point. Negative 200 over 2 times -1/9. But this is weird. Something weird kind of happens here. Or you can just plug this into your calculator. But you basically have positive 100 over 1/9, which really is 900. So 900 maximizes revenue, and you can just plug 900 in for X to determine the actual maximum revenue. Now, to find the price to have the maximum revenue, because those last two aren't hard, but the last one, to find the price they should charge, you're going to take your X value, because remember, this is the quantity. X tells the quantity, and you're going to plug that into the very first equation. 1/9, 900 plus 200 gives you -100 plus 200, which is 100. All right. So note, there's 3 different things being asked here. First one's asking how many units are your X. That's the negative B over 2A. Then for the maximum revenue, plug that into your revenue function. After you do that, you then take that X that you figured out, which was 900, and plug it into the price function to determine the price. Hope that makes sense. All right. And with that, guys, I think that's all I'm going to do in terms of the test review. I think I hit most of the main goals and points of that. So all I'm going to do, we got about 9 minutes. So what I'm going to do is just make sure that everybody has the general overview of lecture 7. And of course, there's a 1-hour video that I created, edited, and put up there just for you. So you all can work on it, but I do want to hit those before you go. Any questions? All right. I should be able to have formal office hours at Friday at 5. So if you have questions, let me know. But if nobody shows up for like 15 minutes, I'm probably gonna go. I will send you a reminder about it, but if nobody shows up, I'm just gonna leave. All right, let's talk about polynomials real quick. And this is gonna be a very quick cursory glance. Because like I said, I posted an hour-long video for you all to, learn more about this. So the first thing about polynomials that you have to understand is that they come, basically it's a bunch of terms, all right? Polynomials can be put in what's called descending order by taking your highest value exponent and putting it first. So this would be an example of non-descending order. To put this in descending order, you do 5x to the 9th first and then 3x. Does that make sense? All right, cool. All right, this will be degree 9. This is not a polynomial because polynomials can only have integer exponents. This is a 1/2, not an integer. It doesn't work out. All right, there's two main types. You have evens and you have odds. The evens kind of look like this. So in other words, if the degree is 8 or 4 or 22, they look like this. If it's odd, they tend to look like this. That makes sense. Simple, not too shabby. Polynomials are smooth and continuous functions. This will be an example of a non-polynomial. It is not continuous and it is not smooth. It has no corners or anything like that. Now, the intercepts of a polynomial are also known as the zeros of the polynomial because they basically, that's where the y value is 0. And the zeros of the polynomial can do one of two things. They can either cross, like these three do, or they can touch the x-axis. Y'all see the difference? Touch is like it goes up, touches, and bounces back down, versus crosses mean it goes from, say, negative to positive. All right. Identifying zeros and their multiplicities. Whenever you have a situation like this, where it's in fraction form, if you look at the exponent on each factor, that tells you the type of multiplicity that you're dealing with. The zero itself would be what would happen if the factor was equal to 0. So for example, if you have a factor of x plus 5, the 0 is negative 5. Does that make sense? So you have a factor of x minus 3, the 0 would be what? 3. Everybody cool with that? That's the difference there. All right, now each 0 would have a multiplicity with it. So for example, you have x plus 5, and this is the only factor of x plus 5. So the zeros you can see is negative 5, and the multiplicity is 1. In this situation, you have x minus 2, the 0 is positive 2, but the multiplicity is 2. Do y'all see how I'm getting 0 multiplicity? Multiplicity just means how many times you see this factor. 2 times in this case, 3 times in this case. All right, form a polynomial whose zeros are given. For example, if I told you, hey, form a polynomial that has zeros of 3 with a multiplicity of 1, negative 4 with a multiplicity of 2, and the degree was 3, then what you would say is, okay, 3 is my 0, so I need x minus 3 to the 1. So basically, I don't need to write it, right? And then I have negative 4 with the multiplicity of 2, so it'll be x plus 4 to the negative 2. Real simple, or to the 2 squared, whatever. And I can tell this degree 3 because this is degree 1, this is degree 2, 1 plus 2 is 3. There are 3 degrees. Told y'all it wasn't too bad. All right, hey, I got 4 minutes, look at me. All right, let's walk through this. So determine the following for the polynomial function. List each 0 and its multiplicity. Why can I no longer see stuff? Okay, it doesn't like me very much. Let me see if I download, because that's about to be a problem. Download it, is it gonna let me? Okay, great. Go back to being full screen here. Boom. All right, so 0 with a multiplicity of 2. Why? Because if I plug 0 in here, then it's a 0, right? So 0 with a multiplicity of 2 and 2 with the multiplicity of 1. So that x minus 2 gives you a positive 0, multiplicity of 1. Real simple, not too bad. All right, now, if you have an even multiplicity, so for example, we've got 0 with a multiplicity of 2, that means that your graph is going to touch the x-axis and bounce off. So for example, if I go to Desmos real quick and I show you x squared, you can see that this is an even multiplicity. It touches and bounces back off. Now, if I do something like this, where I have an x minus 2 on the outside of that, I have an odd multiplicity here at 2, so odd because it's 1, It crosses. Y'all see the difference. Even touches, bounces off, odd crosses. That's the main difference. All right. And so we've got, you can see even multiplicity touches, odd multiplicity crosses. Now the number of turning points is directly one less than the degree of the polynomial. So in this particular situation, you got, so I'm going back to the top again. You got a multiplicity of 2 plus a multiplicity of 1. What is the degree on the polynomial? 3. Everybody see that? So that would be the degree on the polynomial. Then from that, the number of turning points would be 2. And if I go back to the actual graph, you can see where it turns. It turns right here and it turns right here. So it's a degree of 3, but it has 2 turning points. All right. The end behavior just means what happens as you're going towards infinity or negative infinity. So in other words, this function, since it's degree 3, should look like x cubed. And you can see that it does. On the right side, it goes up. On the left side, it goes down. Any questions on that? Real simple stuff, not too hard at all. And like I said, this is all in that 1-hour video that hopefully y'all actually watched or will watch, because I've shamed you into that at this point. All right, using the intermediate value theorem. Intermediate value theorem is real simple. Basically, it says, hey, if you plug in some number, you get a negative, and then plug in another number and get a positive, that means somewhere between those two numbers, you had to cross 0. That makes sense? So I plug in a number and I get like -5, and I plug in another number, say 1, and I get out +5, it had to have crossed the x-axis somewhere. That's the intermediate value theorem in a nutshell. To solve this thing graphically, it's really simple. It's just like with squared or something like that. You basically take the zeros, -3, 1, and 4, and then plug in test points. It literally is the exact same as the inequalities before, so it shouldn't freak you out too much. And then last but not least, I just talked about that. You all can see what I'm talking about. Take the zeros, plug in some test points, determine whether it's below or above the x-axis. We literally just did this, all right? It's just on a bigger scale. That's it. All right, happy studying. Y'all crush this test too, y'all. Crush this test too. You need any help? Email. Yep.
And it went over today, so that's why I was late, but I still sent in. So
that's fine.
I know my last professor like wouldn't credit if you showed up late, but
I don't really care. I mean, I wouldn't go around publicizing it, but yeah. I don't really care. Yeah. Oh, man.
My death day. No, final exam will be my death day.
We've got 2 more weeks. Right
now I'm not feeling good.
Yes. Yeah, I think your breakfast is almost
Oh.